Good morning. My name is Dr. Ripon Padgiri. I'm going to present Rando, a general purpose true random number generator for conventional computing devices. I'm from National Institute of Technology, Silchar. So these are my content. Introduction. Random number generator has many uses in diverse domains. However, security is a prominent domain that requires the finest R&D. Designing and developing a true random number generator is a grand challenge for all time. It is highly necessitated in cryptography and various domains such as simulator and other scientific applications. Many true random number generators have already been proposed, which are very complex and require specific devices. For instance, a quantum random number generator depends on quantum devices. The RNG is classified into two key categories: pseudo random number generator and true random number generator. Currently, the quantum random number generator is emerging. Avesani et al. And Liu et al. Propose a device-independent QRNG. QRNG requires an extra device setup to generate the random numbers. Moreover, QRNG is faster than computer-based RNG. However, the process is very complex to achieve. Erosion et al. Proposes a TRNG based on inkjet printing technology. There is numerous FPGA based TRNG algorithm. For example, Coinche et al. Proposes a FPGA based TRNG. Moreover, the visible spectrums are used to generate a truly random number for 5G cryptography. So diverse true random number generators are devised based on light, image, voltage, current, noises to achieve true random numbers. Still, it is a challenging task to generate a truly random number in any computing devices. So our questions are, can we or a device produce a true random number using any programming language in all computing platforms? Can general purpose TRNG be implemented? Can a TRNG be independent of special devices? The key objectives of our proposed algorithms are outlined below. To implement a TRNG for any computing device that has a clock and a CPU, to provide highly unpredictable and cryptographically secure random number, to devise an algorithm that works on ranging from tiny devices to high-end computing devices. Our proposed algorithm is simple and straightforward, yet powerful. We propose a novel TRNG called Rando. Rando is implemented using non-cryptographic string hashing algorithm and CPU clock. The generated output is tested in NIST SP 822 statistical test suite. Rando passes all the 15 test cases of NIST SP 822 test suite. It shows that Rando is cryptographically secure and highly unpredictable. Non-cryptographic string hashing functions are DJB, FNB, XX hash, superfast hash, and murmur hash function. Similarly, the cryptographic string hash functions are CRC32, MD5, SHA1, SHA2 family, SHA3 families. These cryptographic string hash functions are complex and slow comparative to the non-cryptographic string hash function. Therefore, we select the finest non-cryptographic string hash function for Rando. Murmur hash function is one of the finest non-cryptographic string hash function, similar to XX hash. The values of CPU clocks are measured and it is converted into an integer value. All programming language provides the functionality of measuring CPU clock, including C, C++, Java, Python, etc. But measuring the clock value may differ from programming languages. CPU clock neither follows a particular sequences nor predictable due to background noises and fluctuation. Therefore, it can be utilized to generate random numbers. However, exclusively the CPU clock cannot generate truly random numbers. It requires other parameters to generate a truly random number. Our proposed algorithm, design philosophy of our proposed algorithm is outlined here. We propose a true random number generator, Rando for short, for general purpose computing devices. The design philosophy of Rando is based on the hashing technique, but the string hashing algorithm produces fixed value. Also, the string hashing algorithm depends on the key and seed values, and thus it cannot generate a truly random number. Therefore, we combine string hash algorithm and CPU clock to produce true random number. This is our algorithm. So this our algorithm takes input m as a parameter. So m is the bit size of the random number. So alpha and beta are the two integer value. It is get by CPU clock, and alpha is the input string and beta is the seed value of the string hash function. So the string hash function return a value, and it is assigned to delta. So here the last bit of delta is assigned to bit array bi. So I is the index here. The working principle of our proposed algorithm is outlined here. The CPU clock value are assigned to alpha and beta, where alpha is the input key and beta is the seed value for the string hash function. The delta is the resultant value of string hash function. The LSB is extracted by delta and 1 and assign the extracted value to bi bit array. So here end is the bitwise end operator, I is the index. This process is repeated for m times because we have to generate m bits for the random numbers. The murmur and double x hash functions are used instead of the string hash function to examine its randomness. So we have experimented our proposed algorithm in desktop computer. So desktop computer is installed Ubuntu. So GCC we have compiled using GCC version 7.5.0, and CPU is i7 core i7. So these are the configuration of our experimental environment. So here we compare the Rando algorithm with murmur hash function and double x hash function for 16 and 32 bits in NIST SP 822 statistical test suite. So test name here in the table, the test names are approximate entropy, frequency, block frequency, cumulative sum, runs, longest run, rank, FFT, random excursion, serial, linear complexity, universal. So in the 16-bit and murmur and 16-bit and double x has 32 bits and murmur and 32 bits and double x has. So p value shows that quality of the random numbers, and pass rate shows the success rate of the test. So here the criteria of p value must be 0.01 greater than equal to 0.01 to declare the randomness. So it shows that all test cases are passed by our generated output. So here 64 bit with murmur and 64 bit with double X hash, or 128 bit murmur and 128 bit double X hash. So here also all test cases are passed, and p-value shows that quality of our generated quality of the generated random numbers. So we compare our proposed algorithm with other algorithms, and for example, Rosane et al. And Koenshu et al. So here our proposed algorithm outperforms Rosane et al. And Koenshu et al. So here another comparison is presented. So comparison with comparison of our proposed algorithm with Jiang et al. And Johnson et al. So our proposed algorithm outperforms Jiang et al. And Johnson et al. Here also. And here Golofit paper number 22 and 23, we have compared our paper proposed algorithm with Golofit and Yo et al. Here also our success rate, and that is almost approximately similar or outperform the state of the art random number generator through random number generators. In the conclusion, we have presented a novel algorithm called Rando, designed based on the hashing techniques and CPU clocks. Rando is a straightforward general purpose true random number generator for conventional computing devices, yet compelling. We have also demonstrated the true randomness of generated bits by Rando using NIST SP 822 statistical test suite. Rando is compared with Jiang et al., Rozan et al., Koenshu et al., Johnson et al., and Golovit and Wijorek and Geo et al. Our comparison demonstrated that Rando outperforms the state-of-the-art technique. Moreover, Rando algorithm can be applied in several applications such as security, simulation, and other domains, and it has got diverse applications for generating random numbers, for example, IoT devices. These are the references. These are the references. Thank you.